The Interested Reader podcast is about exploring the world beyond the textbook. We'll cover many lessons in math, physics, and astronomy, and then delve into the mysteries of the universe. Physics is fun, people just don't know it, and I want to change that. I want to spark your curiosity about the world around you and ignite your passion for exploring and questioning. I'm your host, Sarah Tyke. Come with me and let's take a random walk into the world reserved for the interested reader. Hi guys, welcome to the Interested Reader podcast. We're going to do kind of a continuation of the lesson from last week. So last week we started talking about vectors and scalars. We just kind of got into more of the definitions and notation aspects of it. And today we're just going to go through a little bit about manipulating vectors and going through their vector components. So as we talked about last time, vectors have to have magnitude and direction. And we usually write them as a bold letter, or if you're writing them, you're going to put an arrow over the top of it. So we have vector V with a little arrow over the top to denote that it's a vector. So they have components. Usually we're going to be talking about a three-dimensional space. So that's going to be X, Y, and Z directions. So in order to denote that, because we don't typically want to use X, Y, and Z as our direction vectors, because those are actual variables, usually, we're going to use things called unit vectors. So I would write a vector V. I'm going to use the vector A instead. It'll be a little bit more generic. V is usually for velocity, so we'll just go with vector A. So you would have a component, I'm going to call it AX, A sub X, and I'll get to this notation in a second. We're going to do, our direction is going to be an I hat is what we're going to call it. So I'm just going to write this out and then we'll talk about what it means in a second. Alright, so what I have is our vector A has three components. It's going to have an X component, a Y component, and a Z component. So those are going to be labeled with subscripts, X, Y, and Z. So if you're talking about the component of vector A along the x-axis, it's going to be A sub X, and that's going to be a magnitude. So our A sub X, A sub Y, A sub Z are all magnitudes. So because we're still talking about a vector, we have to have direction as well, and that's where these I, J, K notations come in, and those are called unit vectors. So we have our unit vector is going to be I, J, and K. And just so we denote that they're vectors and not just variables, we put this little hat over them. So I will say I hat, J hat, and K hat. And we're not going to use the arrows like we do in our normal vectors, because then that would indicate that they're a real vector. The hat specifically indicates that they are a unit vector. And that means that they have a magnitude of exactly 1. So they're not going to change the size of your vector at all. And they just indicate the direction that your component is in. So that's all they're used for, is really just to indicate direction. So when you have your A sub I component with an I hat, that means that your AX magnitude with an I hat notation means that you are in the X direction, because I is always going to correspond to X. That's just going to be our definition. Okay, so how does this look on our system? So I'm always going to have Y is always going to be pointing up for our axis. X-axis will always be pointing to the right. And so this would be our 0. And then Z would always be, if we're doing 3 dimensions, Z would be coming out of the page, and we'll get to that in a second. So if we have our vector A, we've got two components. We talked a little bit about this when we were talking about triangles, how there's two components. So we're going to have an AX component along the x-axis, and then we're going to have an AY component. If you're watching, this is in red, along the y-axis. And then we'll get to this angle here. We're going to need the angle between the x-axis and our vector is going to be, I'm going to call it theta. So those are our two components. So we have an AX component along the x direction. We have an AY component in the y direction. So our unit vector would just be, if you want to write them on our graph here, our unit direction, or unit vector would just be an I right here on the x-axis, and then j would go on the y-axis, and they would be exactly 1 unit in length. And then again, z is our third component. That would be coming out of the page. We're not going to probably use a lot of z components in our work here. Okay, so that's the basics of the components of a vector and how you write them out and using unit vectors. So I think the next thing we're going to do is going to be, I'm sorry, I'm just going to look through here and see if there's anything else I want to tell you guys about. Okay, I guess calculating what these components are. I think we mentioned this again last time with the triangles, using SOHCAHTOA to get to calculate what is AX and AY. So if we remember from last time, I'm just going to write this out here. So sine is our SO, S-O-H. Cosine is C-A-H. So tangent is T-O-A. TOA. SOHCAHTOA. So this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And, I think I learned this in 7th grade. And here I am at 43, I still use it. Like, it's just weird. Like, you never really grow out of it. You always think that this is so stupid. Who's ever going to use this? SOHCAHTOA. It's dumb. And no, it's the only way I know how to do this stuff anymore. Okay, so AX, if we're trying to find the component, so we have our vector. A is the hypotenuse of this triangle. AX is our x component. So we are looking at the adjacent side of our angle theta. So here's our angle theta. It's the angle between our vector and the x-axis, or the x component. So AX is adjacent to that theta, so we're going to be using the cosine. So it's going to be the magnitude of our vector A times cosine of theta. And then AY is our vertical component. That is the side of our triangle that is opposite of theta. So we're going to be using the sine. So you have your magnitude of your vector A times sine of theta. So that's how you would calculate AX and AY. And again, this A, when I write it, A cosine or A sine theta, that A is just the magnitude of the vector. Okay, so those are our components, unit vector notation. We are going to move on to some manipulation of vectors. Basically, all we're really going to be doing is adding and multiplying vectors. And adding is going to go pretty much like you would expect, where you're just going to add components, component by component. So we're going to get rid of this. So we're just going to kind of do this briefly. If I have our vector A is going to just be our standard AX I hat plus AY J hat plus AK, AZ. I was going to say that sounded kind of funny. AZ K hat. And now when I'm saying like AX, AY, AZ, what I mean is A sub X, A sub Y. Those are the components. I'm not multiplying A and X. And then we're going to have a vector B. Same thing, we're going to have BX I hat plus BY J hat plus BZ K hat. So our two vectors are 3 dimensions. And then when we add them, we're going to write this. We can just do normal algebraic addition. We're going to call it R. It's our resultant vector. So vector R is going to be A vector plus B vector. So all we need to do here is really just add up the components. So R is also going to have X, Y, and Z components because A and B have X, Y, and Z components. So we'll say that R sub X is just A sub X plus B sub X. RY is our AY plus BY, and RZ is AZ plus BZ. And again, these are just going to be magnitudes. If you've got a sub XYZ, those are just magnitudes, so I don't need to worry about the unit vector when I'm writing out these X, Y, and Z components. They're just the magnitudes. And then once you put those all together, so your R vector, it's just whatever Rx is in the I hat, plus Ry j hat, plus Rz k hat. And then you would just put Rx from what we did up here, Ry, you can sub in here, Rz, sub in there. So pretty easy with addition. As far as a picture of it, I'm pretty bad at drawing, so hopefully nobody's actually watching this. So we got our X and our Y directions. So if we have vector A, vectors are always going to add tail to tip. So when I draw my next vector B, I'm going to have to start it at the end of vector A. So vector A ends here with my arrow. Vector B would then start at that arrow there. And I'm just going to have a poor example here because B basically doesn't have an angle to it. So let me redo that so it's somewhat useful. Okay, I'm going to make A a little bit shallower here. Vector A, and then B up here. Okay, so now you can see that you've got a couple different... I am really bad at this. I'm putting all my notation in the wrong areas. It's super annoying. Okay, so we got an AX component here, and our AY component. And then we've got a BX here, and a BY up there. So now all you would do is add, here, I'm going to do something a little bit different here. Make it maybe a little bit easier. And I like to mess around with different colors. So let me just, we'll put B in blue. Sorry about this, guys. Talk amongst yourselves. Alright, so A is going to, we've got red components for A. And then we've got BX and BY in blue. So Rx would just be the addition of our AX component plus our BX component. So I'm just going to kind of, this would be our AX plus our BX would be our Rx. So you just add them, add the components together. Again, pretty basic, I think. I think it should be pretty easy if I've explained it correctly. So let me know if you have any questions about that. And we are going to be moving on here to multiplying vectors. So subtraction would be just the same thing that you're doing here. You just subtract the components. With vectors, you have to pay attention to your negative signs a little bit more because that actually does indicate a positive or minus direction. So if you end up with a negative vector, you would just be on the negative side of our coordinate system. So here I've got, x is always going up. I'm sorry, x is always going to the right, y is always going up. Now if you end up on the left side of that y-axis over here on your x-coordinate, that would be your negative values. Just like if you end up below The x-axis, those would be your minus y values, and with vectors that will actually make a difference. You have to pay close attention to that minus sign. All right, so the next section here is going to be our multiplication of vectors, and there's two ways to do that, and it's not quite like regular multiplication. So addition we kind of see is basically just regular addition. And when we multiply vectors, it's going to be a little bit different. There's two ways to do it. I'll try to center that a little better. So the first thing is not really multiplying vectors, but you can take a vector and multiply it by a scalar. So if you have your vector A with your components AX, AY, and AZ, and you want to just multiply that vector by, say, just some constant C. So C times A. You would just multiply each component by that vector C. So you'd have C in the AX direction, C times AY, and C times AZ. So that's fairly straightforward. Now when you're doing a multiplying a vector times a vector, there's two different ways to do it. And the first way is called a dot product. It's also called a scalar product. So we're going to talk about multiplying. Oh my gosh, look at me, I can't even spell. Alright, so we're going to multiply our vectors. We have a scalar product, which is also called the dot product. And we are going to have a vector product. We'll get to that one in a second. And that is called a cross product. So I'm always going to refer to them as dot and cross products because that's just how I remember them. So a scalar product, as the name suggests, your answer is going to be a scalar. Your vector product, your result is going to be a vector. So let's start with our dot product. Sorry, I'm just writing this out. Okay, so we have a dot product. We're going to write this as, we have a vector A dot vector B. And if you've ever, sometimes in math, you have the multiplication symbol is also used to say dot. Sometimes it's the X, sometimes it's a dot. This is not that type of multiplication because we're dealing with vectors. So if you're doing this, it's really important that you put those vector signs over your A and B. Otherwise, it's going to look like you're just multiplying two numbers. And you're not doing A times B, you are doing A dot B. Subtle difference, but it's very important. And in this case, all we're going to do, since it's a scalar quantity, this is just defined as the magnitude of your vector A times the magnitude of your vector B times the cosine of the angle between them. So cosine phi is what we're going to call that angle. So we're going to have our angle, or vector A, and our vector B. Now if you remember last time I said that you have to do vectors tip to tail, that's only if you're adding them. So right now I'm just drawing the two vectors and I want the angle between them. If I was to add A and B, I would have to shift B so that its vector tail is at the tip, the arrow of A. But I'm not adding them. I just want the angle between them. So the angle between these guys we're going to call angle phi. So when you take the dot product, you're going to do the magnitude of this vector A times the magnitude of vector B times the cosine of the angle between them. Okay. So I hope that it's, and there's a lot more derivation type stuff if we want to get into that, but I think for now that will be enough. That's really the only time you're going to use the dot product. You're not really going to need to go into a lot of other lengthy proofs or derivatives of it. The other thing to notice or to note about this is that because we're talking about a scalar property, you can say that A dot b is equal to b dot a. That will not be the case in our next example. So I think that's it. If you want to write it as, we'll just do this less notation thing here. Since we're talking about unit vectors, if you want to write them out using the unit vector notation, you can write a dot b is equal to, we're going to take all of a the way we wrote it with ax I hat plus ay j hat plus az k hat dot, our b vector would be the exact same thing now, bz I hat, I'm sorry, good lord, bx I hat plus by j hat plus bz k hat. So that's how you could write your dot product with our unit vector notation. And then you just dot the products as you would in our equation. So it would be ax, bx, cosine of the angle, ay, by, cosine of the angle, and so on. Because that's dot product. That one's fairly straightforward. Next, we're going to talk about the cross product. And this one is fun because we get to use the right-hand rule, which is another thing that when I was first learning about it, I thought for sure this is not how adults do physics with the right-hand rule. I couldn't believe it. But it is, and that's the only way to do it. So you can memorize stuff, but it's actually more fun, I think, to do the cross product, the right-hand rule. Okay, so this is the cross product, also known as the vector product. So again, we have our vectors a and b. We're going to do vector a. Let me write this a little bit differently here. So we have vector a, and here we're going to put what looks like a multiplication sign in between them. And then we're going to have a vector b. So the way this is read is a cross b. Now again, it looks like you're multiplying. It looks like you could just say a times b. But since we're talking about vectors, we're not going to be saying that times. It's not a multiplication, it is a cross product. So it's a cross b. When you see it in print, that x will be in bold print. It'll look a little bit different than your typical mathematical multiplication sign. And very often when you get into math and physics textbooks, they don't write a times b. It would just be ab. So if you see it, I think you might look at it and see that looks a little bit different than a regular multiplication sign. So when you're writing it by hand, it's important you put those vector notation, the arrow or something over your vectors to denote that they're vectors. And then you know you're dealing with a cross product. Okay, so what we're going to do is we're going to say that since the result of this is a vector, so we're going to say that this is a vector c is going to be AB, magnitude of A, magnitude of B, times the sine of the angle between them. I'm sorry, that's not a vector C. Let me just start this over. Okay. So we're going to say that A cross B is equal to a vector C. This will make a lot more sense. So we know vectors have two parts, right? We've got magnitude and direction. So the magnitude of this resulting vector C, so that's just a regular C, no arrow, is the magnitude of A times the magnitude of B times the sine of the angle between them, which was phi is the angle that we're using. Okay, so that's the magnitude of C. Now what we have to do is we have to try to get the direction of C. And this is where your unit vectors will come in handy. And this is where we have our cross product, which is fun. So I'm going to have my normal coordinate system where y is pointing up, x is pointing to the right. Now remember when I said that z is coming out of the page? This is how you know, because you'll take the fingers, you're going to have to use your right hand, Make sure you're using your right hand, otherwise it'll be backwards. Your fingers go in the direction of the y-axis, so pointing off to the right. And then you curl your fingers toward the y-axis, and your thumb is pointing up out of the page. If you're watching me, I'm doing this. If you're not, you're just going to have to imagine what I'm doing. Okay, so you put your fingers in the direction of x, curl toward y, and that means that z comes out of the page. Okay, so what that tells us is that x, I'm going to use the hat because I'm just using a unit vector, x hat cross y hat is equal to z hat. So you take your unit vector, remember those hats are unit vectors. I use ijk for standard, but you could use x hat, y hat, z hat. So you put your fingers in the direction of your x direction, you curl them in toward the y-axis, and then your resultant is the direction of your thumb, in this case z, and it points up out of the page. So x cross y is our z direction. So whenever you're doing a standard Cartesian system where you've got y pointing up and x to the right, z will always be out of the page. Now if you were to do it the other way, say you wanted to do, well, I guess I'll get to this in a second, but remember how we said that a dot b is equal to b dot a? In this case, if you did, what happens if you do y cross x? If you do your y hat direction cross x. Okay, now you've got to do some gymnastics here. So your fingers go in the direction of the y, curl them down toward the x-axis, and now your thumb is pointing into the page. So that now means that z is going the opposite direction. So y cross x is actually minus z. So x hat cross y hat is equal to positive z hat. But if you reverse that and you go y cross x, you get a minus z. And also, if you do the right hand rule with your left hand, you'll also get the wrong direction. So always make sure you're using your right hand. I've heard stories about a lot of people, most people are right-handed. So during their exams, when they're writing with their right hand, they're just sitting over here with their left hand doing their right hand rule. And as long as you're accounting for the sign difference, it's fine. But if you're not, all your answers are going to be the wrong sign. So that's the right hand rule. That's how you would determine the direction of your vector c. So as far as I can remember, I don't think there's any other way really to do that direction. So it's really just that right hand rule, which I thought was hilarious because I couldn't believe that that was how we were doing physics. You're sitting here, with your hand and curling it left and right, but it works. I mean, and that's how you do it. Again, I guess just for complete here, we'll make sure we define our angle phi. And so our angle here. Now the physics books will make a note of making sure you're taking the smaller angle of the two. So again, if you're watching, I've got my A and B, and there's this angle phi between them. Technically, there is another angle between A and B, and that is this big angle that swings around more than 180 degrees. Don't use that one. I can't imagine why anyone would. But again, I mean, you can draw the angles however you want. So I mean, I guess there may be a time where that isn't the case, but always use the smaller of the two angles between A and B. Okay, so that is our cross product. The magnitude is AB sine, and we'll just write this out as an actual rule like we did before. So we have A cross B is equal to the opposite of B cross A. And then the direction of C is given by your right hand rule. Okay. that is all I have for vectors. We talked about unit vectors. We talked about adding, multiplying vectors, our dot and our cross product, the right-hand rule. I think that's all I have for vectors. I think next time we can probably head on to the next lesson, which is we're gonna start talking about motion. Basically, I think we're just gonna start with the one dimension, easy. But that will be it for vector notation. Obviously, it will come up vectors, triangles. That's going to be throughout all of physics. So, if you have any questions about that, let me know. You can go to the Facebook page, go to my website, send me an email. And I think that's it. So I'm going to take a break right here, and then when we come back, we're going to finish the rest of our discussion about scalar energy. So last time we talked about kind of the definition of scalar energy, and this time we're going to talk more about some of the effects that you see of it, things that really are not really explained, so it's going to be difficult to find your normal mainstream published papers, just because people don't talk about scalar energy as if it were a real thing. So we're going to talk about that today, which this is the best part of it, I think, is getting into the weird stuff that nobody wants to talk about. So I'm going to take a break here, and I will come back and we'll get this scalar energy discussion started. Thanks, guys. All right. Hi, guys. We're back again to talk about scalar energy. So I also didn't realize that lesson was like half an hour long. So that's not what they're supposed to be. I mean to keep them only about 5 or 10 minutes, but there's a lot to talk about with vectors and the weird notation and all that. So hopefully you were able to get through it. If not, I'm sorry. You can berate me on the group page or an email. Be brutal. I can take it. All right, so here we go with our second part of scalar energy, which I think is going to be hopefully pretty interesting. So like I said, I think last time we talked about more about the mathematics of it, a little more the detailed about it. What is quantum entanglement? This whole idea of superposition. But just to kind of recap here with our scalar energy, it's basically when you have two opposing waves collide, their directions, since they're vectors, would cancel out, but their magnitudes would not. So you're left with what's essentially a standing wave that has no direction, which is, the theory is that it's everywhere all the time. And that's how you have this action at a distance, as Einstein called it. That's just sort of instantaneous communication. So then we got into quantum entanglement, where you can have two particles that basically have been, I hate to use the same word, but entangled. So they're sharing some component that when you separate them, even supposedly by light years, they can still instantaneously communicate with each other. So if you measure one, it forces a measurement or a state in the other one instantaneously. So that was basics of quantum entanglement. And then let's see here. So we got into this kind of thing with how entanglement doesn't actually violate relativity. The information is not actually being sent faster than the speed of light, which would violate relativity. And scientists tend to think of entangled objects as being one object rather than two separated. And basically there were experiments that were done where if you view these particles from different angles, that seems to kind of explain how you can be two states at once, because it just kind of depends on how you look at it. And then of course we had the Futurama clip, which is my favorite, about the quantum finish with the horse races. Okay, so that was kind of the science behind it and what mainstream science says about scalar energy, which is basically that it's all just BS and they don't want to talk about it. But they do want to talk about quantum entanglement, which to me kind of sounds like the same thing. But that's my opinion. Okay, so today then we're going to get into, let's just say that scalar waves, that it's all real, that it all exists, that we do have these things called scalar waves. What are people studying with them, and what effects are people seeing from these things? So there's a good paper about scalar waves and consciousness. It's kind of hard to find a lot of really like scientific papers about this sort of stuff, just because again, they don't really get peer reviewed because everybody thinks that it's just nonsense, and that's what peer review is, basically a popularity contest. So if you don't agree with everybody, you're not going to get peer reviewed. So the idea, though, is that scalar waves can carry information because they're still waves, just like you have, an electromagnetic wave carries information. It can carry a sound. It vibrates the air. It vibrates at a certain frequency. It has information associated with it, and so they think scalar waves do too, because they're a standing wave. They just don't have direction. They just kind of go everywhere. And our thoughts are considered scalar waves. At least from what I don't think anybody's ever come out and said thoughts and emotions are scalar waves. But to me, that's, from what I've researched, it kind of sounds like that's what they are. You could describe them as that. And so your intentions, your thoughts, your emotions can generate these waves that influence your body. They've measured, they know that when you have a feeling, you have a biological reaction to it. You can measure your blood chemistry when you're scared. You can measure there's adrenaline that gets pumped into your bloodstream. But what if that fright is not really because of, a bear chasing you down? What if you just were thinking about something that, was kind of scary or sad or happy? You're just thinking these thoughts, they're not really going on, but your body still produces the same physical reaction. So obviously those things have been measured. It just seems to be that people are just like, we don't know why, and we don't know what to call it. And I think everybody's probably had a gut reaction where you can just, you can feel something, like something is happening, you feel like physically sick because of something that's happening, or you've thought of something, like it's just like, oh, I forgot to turn the oven off, and just this thought makes you feel like kind of sick. And again, you can, whenever you're in meditation, or you're at a doctor's office and they're about to rip a tooth out, and they're like, oh, just think of something pleasant. Like when I was pregnant, I had a real problem with high blood pressure, and so before they would have me get the measurement of blood pressure, they would say, well, just imagine a peaceful scene, imagine being on a beach somewhere, because imagining a peaceful scene will actually lower my blood pressure. Now that didn't always work, and I ended up with all sorts of issues, but I think everyone knows that when you imagine something peaceful, you feel peaceful, like physically, and it can be measured. And there were times when it did work at the hospital, and if I, did think of a calming, peaceful situation, my blood pressure would be measured as normal. So these things do happen. So our thoughts and our intentions do affect us physically. That's a real effect. And is that scalar energy? And then we also have the placebo effect, which I love. I think the placebo effect is amazing. Everyone likes to just blow it off like, oh, if you're feeling better, it's just the placebo effect. Do you understand what you're saying? You're saying that you didn't take any medication, you didn't do anything except think about being better. And you were. You thought yourself healthy. You didn't do anything else. You didn't take any medication. You didn't go to a doctor. You didn't do any physical intervention. You just thought that the thing worked. And now you're better. That's huge. That is that's impressive. I don't know why people have always just sort of dismissed it like, oh, placebo effect, like it's no big deal. Like, well, it's real. I took the pill, now I don't have a headache. Oh, but it wasn't really headache medicine. It was just a sugar pill. Oh, well, I don't have the headache anymore anyway. That's a big deal, isn't it? You just thought You didn't have a headache anymore, and now you don't. That's the power of your intention, of your mind. And those thoughts are energy. I mean, something's going on, something's being generated. And what is it? I would say that that's the scalar energy. And there's also this phenomenon, I think probably you can like feel when someone's looking at you. And if you've ever done this while you're out and you stare at someone, I end up staring off into space, and I think people think I'm looking at them, but I'm not. So I have to always kind of make sure I'm looking down because I tend to just zone out. But sometimes you can kind of feel when someone's watching you. Well, what is that? Like, what is making you physically feel like it? There's something about that person and either their intention. There's something that's communicating between you two. I mean, I can usually tell when somebody walks into a room. That's a little bit different because now there's a physical presence, but a lot of people say that they can't. And I'm like, how can you not feel that somebody just walked in the room? Like it's another presence. You just feel them and you can't explain it. And I think that's why this topic gets avoided in mainstream science, is because you can't explain it. I can't explain how I can just feel somebody. I can't explain how I can convince myself that I don't have a headache anymore. Even though I either took not the medicine, or in experiments you take the sugar pill and suddenly you're better. It's the placebo effect. You can't explain why these things happen, so nobody really wants to go in and research them. And you can't, and I think that's the best part about life. I think are some of these things where you can't explain them, you can't research them. Not everything is able to be picked apart by science. It's fun to just experience it and just accept that, yeah, we are that powerful. Our thoughts, our minds are that powerful that we can just think ourselves better. And I don't know how true this is, but I mean, I've heard that in some cultures, I think Japan is the one that I've heard, when people get a cancer diagnosis, a lot of times they just don't talk about it. They're like, okay, cancer. And then they end up just kind of living their normal life, living their normal lifespan. It never really affects them. But what do we do here in Western culture? Someone gets a cancer diagnosis, and my God, we give it all our attention. It's the chemo, it's the therapy, it's everything. And people are like, oh my gosh, are you okay? And I'm so sorry, and it's this and that. And it's just like our whole life now becomes consumed by this idea of cancer and how we're going to die and how we have to find a cure, and we have to do the medicine, we have to do everything. We just obsess on it for the rest of our lives, and then we end up having a shortened life. Other cultures are just kind of like, okay, I'm just going to keep on living. They don't give it any attention. They don't give it any energy. We tend to just give it all of our energy. All of our life goes into this cancer diagnosis, and big surprise, it ends up taking our life. Again, I don't have the sources and the documentation for this. There's things that I've heard, and I typically don't agree with our Western medicine, and I think we end up putting way too much importance on medicine. Obviously, it has a place. Medicine, surgery, everything has a place, but so does our mind. So does our intention. Okay, so that's kind of my spiel on the scalar waves and consciousness. That I think our consciousness probably is scalar waves, and I think we've all experienced it on some level. Maybe we don't want to call it scalar waves, but I think we've all experienced these things. So a lot of alternative healing therapies kind of use this idea that scalar waves can resonate with physical objects and systems, and scalar waves can affect how physical systems behave. So things like acupuncture, sound therapy, biofield therapy, which we can get into later, are all these alternative healing therapies that use this idea that there's a field that permeates us, that resonates. And if we can bring our body into alignment with that natural resonance, that scalar field, then the body can heal. And there is some evidence of this later on we'll get to about the Earth's natural resonant field. So all of these alternative therapies like acupuncture, biofield therapy, they're trying to align the energies in your body and to restore your energetic balance. And it's well known that the human body has an aura, that we do radiate energy. And there are these nodes up and down our spine. Traditional medicine, I think, just calls them nodes or nerve centers, but you'll also hear them in, I believe it's hope I don't get this wrong, in Indian medicine, the Ayurvedas, the chakra system. So I don't know if you've all heard of the chakras. There's 7 chakras that line from the crown of your head down to the base of your spine. And each of those chakras aligns with one of the physical nerve nodes along your spine. And so everyone knows that these things exist. Again, whether or not you're in Western medicine, you want to just call them, nerve nodes, or you're in a more spiritual based, or basically any other medicine system, you might call them chakras. But they're all there, and everybody recognizes that they're there. They're all these energy centers. So our body has these energy centers. And so there are all these alternative therapies that try to align those energies and try to balance energy in the body. And really, we are all just energy anyways. I mean, even an atom, which we usually describe as the proton, the neutron, and the nucleus with the little particle electron spinning around it. Each of those particles, the electron, the neutron, the proton, can be represented as an energy wave. And they're made up of quarks, which can also, we talk about them as particles, but they can also be represented as a wave. Everything can be represented as a wave, and we can get into this later about particle-wave duality. So when you break it all down, we really are all just energy. We're here kind of manifesting as a physical object. Obviously I'm not just floating around as an energy wave, but at the very smallest scale, you could break it down to just energy, to waves. So scalar waves resonate with our physical body because we are energy as well, and we're kind of living in this, again, science will call it a Higgs field. Ancients called it the ether. So there have been people who have studied scalar waves and tried to describe them, with our standard scientific principles. So there's a thing called quantum coherence, which is very similar to quantum entanglement. And there's a paper, if you're watching, that I have pulled up on the screen here that kind of describes the difference between quantum coherence and quantum entanglement. And basically, in this paper, the headline is that physicists find that these two things are two sides of the same coin. So they're very similar. Quantum coherence describes a scenario where an object's wave property is split into two, and then those two waves interact coherently. And so coherently basically means that you have two waves that are in the same phase. So if they were to add up, they would magnify each other. You can be out of coherence or incoherent when they're out of phase, and then they basically cancel each other out, and you can get static or noise if things are incoherent. So coherence, you're talking about this correlation between the phases of a wave, of two waves. Okay, so if you have quantum coherence, you have your object. Again, we just said that we could describe objects as waves. So you have your wave property, you split it into two pieces, and then those two pieces interact in coherence. They're in phase. So that's quantum coherence. And then quantum entanglement, we kind of described before, where we have these, two particles have been connected in such a way that when you separate them, they're both still kind of communicating or sharing some property. So again, from this paper, physicists basically say that they're operationally equivalent. So basically they're going to operate the same way for all practical purposes. They're the same, but the concept is still different. And I think, to me, the difference is rather slight, and to me it's minimal, but if you're into this, I'm sure there's a bigger difference. It was reading through all the definitions of these two things, you just kind of come away thinking it sounds like they're saying the exact same thing. So both of them are based on this principle of superposition, where you can take a single quantum state and it simultaneously exists as multiple states. So another way to say it is you could take a bunch of different wave forms, wavelengths, add them all together, and get a new wave. So your new wave is just a combination of all these different other types of waveforms all packaged into one. And both quantum entanglement and quantum coherence use this principle of superposition. So in coherence, you take a single particle, represented as a wave, you split it in two, and now those two waves interact with each other. And this Schrodinger's cat is supposedly this example of quantum coherence. I've always heard it described as quantum entanglement, but from some of this research I did, people were using Schrodinger's cat as an example of quantum coherence. And if you don't know what Schrodinger's cat is, the idea is that you have a cat in a box, and I think there's supposed to be some sort of radioactive clock that at some point just detonates, and so you don't, at some point the cat is dead or dies. You don't know if he's dead until you open the box. So the cat is inside, something happens, and you're like, is he dead? You don't know. You have to open the box to know. And the idea is that until you open that box, the cat's in both states. It's alive and dead. You just don't know until you actually look in there and physically see what happened. So then quantum entanglement, you basically have two particles that have a shared state in that superposition that we talked about. So it's kind of like quantum coherence is one particle that's been split into two waveforms. Quantum entanglement, you start with those two waveforms and they can communicate with each other. Very subtle difference. But again, I'm going through all of this because we want to say that because of this property of quantum coherence and quantum entanglement, we have this idea that there's something that can act at a distance without being in physical contact with each other. And that's our scalar wave. So we have these non-local connections, this instantaneous exchange of information. And it can be across, supposedly, galaxies, light years. And it's the scalar waves that are doing it, and they exist because of quantum coherence and quantum entanglement. So, if our thoughts are these scalar waves that are supposed to have basically no time, no direction, they're kind of everywhere all the time, can our mind influence distant objects? Since if our thoughts are scalar energy, scalar waves. And here's this thing of, we've all heard of telepathy and telekinesis, where you can move an object. Obviously not many people, not everyone can do it, but there are examples of it. People have done it. They have moved objects. There's also remote viewing, if anybody's ever heard of that. I think probably everybody's heard of the movie Men Who Stare at Goats. That was based on actual military experiments with remote viewing, and that's a fascinating subject, which we can also at some point get into. But it's the sort of thing where people essentially project their mind to a certain location and see what's going on. And some of these people, when they're trained in it, they get it accurate. So accurate that the military is using these people. They are using remote viewing for, data collection and, I would assume for spying too. So, it does exist. There are these things. And then you got distant healing, the power of prayer. I think everybody's probably heard of that. I know I have, some of the podcasts I listened to, they would just say that they, one of their listeners, had a child that was going through therapy for leukemia. I think they were like 4 years old. They had very severe leukemia. Not a good, prognosis. They were given a couple months to live, maybe. So the host of the podcast just says, hey, if you guys just say a prayer for the little girl. Didn't give her name, nothing. Just she has leukemia. Just say a prayer for her. So I did, and I imagine most of the people listening to that show, we were all kind of of that same mind. So I don't know who all did what, but a few weeks later, the host comes on and says, yeah, so that little girl, her leukemia is gone. Not just in remission, not just, getting better, gone completely. Like she never even had it over a couple weeks. Doctors had no idea. They couldn't figure out, they had no explanation. The girl's just cured. And maybe something else happened, who knows, but here you have a host asking for people for prayer. Now there's a lot of people who probably all said it. We don't know who this girl is, don't know where she lived, don't know her name, nothing. But a few weeks later, she's completely healed. Something happened. And I hear that on a lot of the shows that I listen to, where they will ask somebody, somebody struggling with whatever, and you'll hear back a few months later, and they're cured. I mean, their cancer's in remission, their leukemia's gone. One guy, his son had a really severe drug addiction problem. He just didn't know what else to do to help this kid. So the host of the podcast gets on and asks, hey, if you guys can just, say a prayer that this kid, whatever, he straightens out. He gets, whatever he needs in his life. And, a few months later or something, the kid's completely clean off of all drugs, alcohol, steady job, completely turned around. So, I mean, definitely, even if we haven't all experienced this ourselves, I mean, it's going on. And there's another group, I can't remember the name of it, but it's like the Heart Project or something. But so they have times where, if you're a member of this organization, you can go online and join them. It's all free. I used to do this. I don't remember the name of it, though. It's been many years. But they all get together, and so at a certain time, they all have a prayer or meditation session. Again, you don't have to be religious for this. It can anything. Just that you're essentially asking a higher power for some sort of goodness and peace and love in the world. It doesn't have to be a higher power. You can just ask for, can we just have peace on this planet? And so everyone gets together in this group, and wherever you are, you don't sign in to do at the prayer time, but wherever you are, you're like, okay, it's noon today, local time. Or maybe they even have a set time, like we're all going to do Eastern time. I don't know. But everyone gets together and they just have this mindful, uplifting prayer, meditation, thoughts, whatever you want to call it. And they have measured, like, increase in energies, or I know there's decreases in crime in areas when this happens. When you get large groups of people praying, they can actually measure decreases of crime in the area. I mean, who knows? Is there a correlation? I don't know. I like to think so. I believe so. So again, this is something is going on. Something with our thoughts and our attention is affecting physically this world somehow. And again, I think that's the scalar waves in action. So some theories say that scalar waves and consciousness are connected. So again, what we think and our thoughts are scalar waves, and it's the same sort of thing. So our consciousness can affect the physical world by influencing quantum wave functions. So again, because we can all be represented down to a quantum level of energy, and our thoughts are energy. So my thought that's a waveform can affect my physical brain, which is technically a waveform at some level. So these energies are all just interacting and affecting each other. That's the theory behind scalar waves and consciousness. And Rupert Sheldrake developed a theory called morphic resonance. So he's a parapsychology researcher, he's a biochemist, Harvard scholar. And his theory of morphic resonance suggests that there's a field of information that connects all living beings, and that scalar waves would carry this information. So we're basically just living in this field of scalar waves. So our thoughts can travel through it as scalar waves and affect each other. You can have your normal sound waves, your electromagnetic waves. But we have this field of waves, of scalar waves, all around us all the time. And again, this kind of sounds like, I think it kind of sounds like the Higgs field that scientists like to talk about. Okay, so a couple examples of the scalar waves in action here. So there's a paper that was written by, I can't remember his first name. It's Rien, R-I-E-N, I believe. So in 1988, he wrote this paper, Interactions with Scalar Energy. And the first time I saw it was in this CIA paper. And they were studying the interactions of scalar waves on biological tissue. And what this guy had talked about specifically in the paper was this watch called a Teslar, Teslar watch. And if you're watching, I've got it on the screen here. They have a website, teslar.com, Teslar.com. And it's mentioned in this paper in 1988 that it's a watch that produces a scalar field. And they actually did tests on this mechanism using this watch on tissue cells in a petri dish. And they actually showed this with all their data, their scientific method, everything, that when they put this watch near the biological tissue, the cells, whatever was being produced by this watch, the scalar energy, the scalar waves, activated the RAD6 gene. And that gene increases the activity of ubiquitone, which is a protein that is used to repair DNA. So this watch was shown, beyond doubt, to actually facilitate DNA repair. So that was pretty, I thought that was pretty huge, and you never hear about this. I didn't know about this thing. And they've got a website here where they have a little wearable. The watch is like, I think it starts about $800, but they've got just a wearable, just a bracelet that's $200. So this watch has a chip in it that produces this frequency of 7.83 hertz, which is the Earth's natural resonance. And I think I mentioned this a little bit earlier, that we're going to talk about the natural frequency, the natural resonant frequency of the Earth. And that's what it is, 7.83 hertz. It's also called a Schumann resonance. So there's a series of these things. But 7.83 hertz is considered the Earth's sort of natural vibration. It just sort of resonates and kind of hums at this 7.83 hertz. So this Tesla watch has a chip in it that constantly produces this field, 7.83 hertz, and you wear it, and it's supposed to affect the meridians. Again, we've got these energy meridians through our body. Everybody knows this. Whether or not they want to admit it, we have energy meridians through our body, and this watch activates some of those at that frequency. So it resonates at 7.83 hertz, and it affects these energy meridians in your body and helps facilitate your body making this, this was the one example of this, ubiquitone, to help DNA repair. And it's been shown in other cases that when your body's exposed to this frequency of 7.83 hertz, such as Earth's natural vibration, it has been shown that people just feel better. Physiologically, there are symptoms like their blood pressure will decrease, heart rate might lower, but people just report feeling less stress, less depression. They sleep better. Even if you can't measure it, the testimony is that they just feel better at this frequency, which is the Earth's natural frequency. If we could just experience that without all of our other radiation from all of our electronic devices. And just outside, you go outside, it's not like, even if you don't have your phone, your computer, you're still bathed in, this radiation that we have from all of our cell towers. And anything that's moving, really, like all our cars produce a field around them, our air conditioning units, our heaters. We're just in an electromagnetic field all the time. So when you get out of that, and this is why people like to do what's called forest bathing, you get away from all of that and you just go out in nature. You go sit in a forest. And I'm guessing that even if you don't know what's going on, it's probably because now you are closer to that resonant frequency of 7.83 hertz. You can actually feel that vibration. You can feel the Earth without any interference from any of our other magnetic pollution. So that's what this watch is doing. And people report, again, improved sleep, cell regeneration, decreased depression, decreased fatigue, just amazing health benefits from wearing these watches and from being at that 7.83 hertz. So that's, I think, a really cool one. That's, I think, the only one I really found that was available for consumers. We'll talk about a couple here in a second that are scalar energy centers that you can go to, but this one, for $200 you can kind of have this wearable device. So I'm just going to go click on it here if you're watching. So here they've got just these wearable bracelets. They're kind of cool looking, and they start at $195. Oh, I'm sorry, $175. And then, like I said, their watches go up to like $800 or $1,000. But that's pretty cool. Yes, this was mentioned in a paper in 1988. Actually by name, this company. I think they're called ELF Cocoon. ELF means extremely low frequency. I assume that's what they're going for. But yeah, it's just pretty cool. So the next thing is scalar energy pendants. And I actually have one of these. I'm going to show you a picture here. So if you're watching here on screen, I don't know if this will show up. No, that'll show up there, I guess. So there's the deal with these scalar energy pendants. I'm just going to show you here. We'll get to what this picture is in just a second. So the picture I'm showing here is a bunch of different types of what they call scalar energy pendants. So they're usually made out of lava rock or natural minerals. Often you'll see that they're made from Japan. And so the problem is that they are also a little bit radioactive. So the picture I'm showing you here is from the NIH, talking about how these pendants are radioactive and they're not good for you to wear. So there's a whole bunch of different kinds. I didn't know there are this many. I actually have this glass one here called GP11, and I believe that was found to be. So the paper says the products were 10 ceramic based and 4 glass based, 5 metal. I don't remember where I read it, but the glass one had a highest rate of something. I don't remember now. Okay, well, I won't bore you guys with that. But anyway, so let me just see if I can switch over here. So I have one of these quantum pendants. It's by a company called Quantum Science. Supposedly, that's what it says down here. I could not, for the life of me, find anything about this company online. Whenever you search for Quantum Science, quantum pendant, it just comes up with basically buying this product. Essentially, it looks like it's just, I don't know, like if you ever tried to do like drop shipping or something where you just have a manufacturer just has tons of these cheap things. That's basically what this seems like. They're not expensive. I think this was $20. And I'm like, hey, I'll just try it. If it's a scalar energy pendant, why not? So, and I've wasted $20 on far less in the past. So I was like, I'll just give it a shot. I've had this for a while. This has been several years now. I just kind of, it doesn't work for me. I don't feel any sort of benefit from it at all whatsoever. But it's also kind of clunky to wear. So it has this authenticity card here. It just says it's Scalar Energy FIR card, which I don't even know what that means, but so I have, so mine is this glass one here. It just kind of looks like, it looks like just green sea glass, honestly. If you've ever been to the beach and picked up a piece of worn, smooth glass, that's what all this looks like. There's a little bit of a design. I'm going to see if I can kind of show it here if you're watching. There's just kind of like little circles etched into it. You got one in the center and then what, 6 around the outside. I've never been able to find out if that means anything. A lot of the pendants seem to have this sort of design or some sort of take on it. And if that helps, it does not really help, sorry. But there's also some that are just have like a yin and yang design on them, so I don't know if that design really means anything. But yeah, so that's, it came with this chain, which I find to be, it's too long for me to wear. It's very heavy, it's very clunky, so it's not at all comfortable to wear. I tried it for a little while. I think the idea too is you can just wear it, you can just keep it in your pocket as long as it's by you. But again, I didn't notice anything from it. I thought it was cool to try it, and it just didn't work for me. But it's still cool. A lot of people find that it does work. I mean, if you look at some of these sites with these reviews, people do like them. They do find some benefit out of it. So, you know, I mean, I'm of the opinion that anything is possible. And a lot of things don't work for me anyway. Like a lot of medications, a lot of substances don't actually have an effect on me, so it's not too surprising. So this picture here, again, this is just the example from the NIH about what pendants to not wear. Stay away from them because they're bad. No, I mean, this one I think did have, they did find fairly significant findings. I thought they said that some of them were found to expose the user to 2 millisieverts of radiation per year, and the maximum allowable is 1 millisievert per year that you're supposed to get. This assumes that you're wearing the pendant for 2,000 hours, which isn't all that long because a lot of websites say to wear it all day, 8-10 hours a day. If you had 2,000 hours in a year, I mean, you're talking about 2 hours a day, right? Yeah. I mean, if you work for 10 hours, that'd be, I guess 10 hours would be a 200-day wearing time. But, I mean, again, these websites will say just wear it all the time. All day, every day. So it's not an insignificant amount of radiation that they found. I don't know if there's any comparison, like, to what, I mean, how much radiation you getting from your cell phone or your computer or going through the airport. But I think that's all in there somewhere. But anyway, so that was kind of interesting that, when you search for quantum pendants, at least when I did, most of the websites, the first ones that come up on the first page of searches are all government agencies saying, don't use them, don't use them, don't use them. And I get if there's some radiation, you do want to know that, because no website has ever said it. Like, when you go to buy them, there's no indication. There was one, I think, that did mention that there might be some slight trace amount of radiation, so be careful. But I just thought it was funny that anytime there's like an alternative type product that might have a healing claim, all the government agencies get out there and say, don't use it, don't use it. For God's sake, don't do anything. Okay, so that was scalar energy pendants. Again, they're not expensive either. It's one of those things where it's kind of like, you see the watch that, or the wearable bracelet from the one company for $200. You think, okay, maybe that's probably, I mean, they're actually generating a scalar field, but I mean, this little glass thing that I have, like, so it was like $20. I'm like, is it really this miracle device for $20? I mean, I don't know. I guess you can try it out for yourself. You can find them pretty easily online, so just be aware that they might be radioactive. Okay, so then there's another type of scalar healing, which actually uses a scalar energy chamber. So there are these 4 frequency generators. You put one in each corner of a room, and you orient them in pairs, like so the 2 diagonals facing each other. And each of the pairs produces a wave function. Again, it's in opposite direction because they're pointing at each other, so they're going opposite directions, the waves. So the waves come together, they collide, they produce that scalar field. So that's the idea. So they've got these 4 generators set up around the room. So it leaves the room just encased or basically in a scalar field when you have these 4 things. So that whole room is just filled with scalar energy. So one of these places is called the Scalar Healing Center. And I'll just pull this up on the screen here. So this one is in Arizona. So in this one, they actually have demonstrated a reduction in seizures. This was peer-reviewed a clinical trial that got published. It was basically a 4-year-old girl went from having 6 to 8 seizures a day that lasted 10 to 20 seconds to 1 to 2 seizures per day that lasted 1 to 2 seconds after about 2 weeks of treatment in this scalar wave chamber. I think it was done at this Arizona center here. And so this was kind of cool. So it's Bioscalar Energy Enhancement System. I'm just reading from the website here. It's technology created by Dr. Sandra Rose Michael about 40 years ago. So people have been using this stuff. And again, it's one of these things where people will use this and they'll just report just amazing healing benefits from being in a scalar energy field. I think there was one that even said that there was some regeneration of bone tissue, like they fractured a bone or something, and after being in this field, I don't know how long, I think you stay in for like an hour at a time, but their bone actually started healing. And that was the only treatment that they had. That was the only difference that they had done to their treatment routine, was to go into the scalar energy field, and the bone started healing. And I think this site here, or this center, I think they only charge like $60 for an hour. I'm like, dang. I'll pay $60 to go in an energy field. That'd be awesome. So they've got, on this site, if you're interested, scalarhealing.com is the website. And they've got some different papers and testimonials. But this is going on. I mean, this is an actual place. They actually have generated scalar waves that people are experiencing. I'm just kind of scrolling through some of the testimonials and see if they say. A lot of people also experience just better, like, meditation practices. I know if you're into meditating, it can be difficult. Sometimes people don't even bother getting into it because they've tried and it's too hard to stay focused, or it's too hard to to not think about things. But a lot of people go in this scalar wave chamber and they say that it's so much easier. And some people say they have visions. I mean, who knows? So here's one that says she has a friend who had chronic pain, the other pain due to bone cancer. They had a 2-hour session, felt completely better. I mean, not that they were healed, but they just felt, the pain was gone, at least for that time. My body feels alive and well, deep peace. So, yeah. So, I mean, a lot of these people, I think it's a lot of mental and emotional help too that people are going for, it looks like. But there have been case studies of people actually, having the physiological improvements of, lowered blood pressure. There have been drops in blood sugar, like diabetics will experience actual lowering of their blood sugar. The seizures had been a thing that had come up a couple times. Repaired muscle, bone tissue, pain control, reduced anxiety. So there's another company that does this called EE System. Well, it's Energy Enhancement System. Their website is eesystem.com. So this one actually has a setup that you can buy for your house, and it ain't cheap. So I'll just see if I can get, so on the page here, if you can watch, in the middle here, this is the setup that they've got. So there's this little cube that's got like computer monitors around it with these weird little like colored, almost looks like colored static. So these are, I don't think, from what I could tell, these are just the monitors to produce a visual display. The actual scalar wave generators inside this cube here that's in the middle looks like a pillar with these monitors around the outside. Hopefully you can visit this and look at it, because it's pretty cool looking. I think I'm a little creeped out by the static, because I don't like static. Don't ask me why. It creeps me out to see static on TV screens. If there are TV screens that have static anymore, I mean, you need to. That's probably pretty old to know what static is anymore. So this is just an example of theirs there, and I think they have. Let's see if I can find the. So the EE System. So it's normally just like 4 monitors or 4 boxes that you can set up around your room. So these are some pictures they've got here. I don't know where this is, but it's just an example of one of their setups. So here it says they're all-inclusive pricing for one of these systems, which is 4 units. You can do multiples of them if you want, but you need at least 4. All-inclusive package pricing starts as low as $28,000 US. And they'll ship it and install it and all that. Or they have, let's see here, the EE Cube, which is what I showed on that first page, which is just like a little pillar. So here's a picture of it here, just like a little black pillar with these monitors around the outside. And that starts at $15,000. So it's really interesting. I mean, I love the fact that they've actually have products that are generating scalar waves. I mean, this is what Tesla was trying to do. And now you've got at least 2 companies here that are doing it, and you can, well, 3, I guess, because if you count the watch company, that are actually, they have units that are producing scalar fields that you can actually experience. I think the watch is a pretty cool idea, or at least the wearable for $200. It's just a bracelet. And again, it's one of these things where you can go through and you can look at some of the testimonials, some of the research that these people have been doing. And I mean, everyone who experienced these scalar fields, I mean, everyone comes out feeling better. And again, it's one of those things where maybe you can't always measure it. You can only really go by what people say, like, oh, my pain was reduced, my pain was gone. Okay, maybe you can't actually put a measurement on that. But it's what people are saying, it's what they're feeling. And maybe it's just the placebo effect, who knows? But if it's the placebo effect, then that's just their mind being so powerful that they can just heal themselves by thinking about it. And again, you have to actually believe in it, because how many times you thought, oh, I just want this headache to go away, but it won't. and then either you stop thinking about it, or you take, I don't know. I mean, I guess aspirin never works for me, so I take it anyway, hoping for placebo effect. I'll just take a couple aspirin, and I think mainly I just forget about it. I think it just sort of tricks my mind into thinking that, hey, you did something, now forget about it, and then my headache does go away. But it doesn't always work, so I need to take a lot of aspirin sometimes if I need to get rid of a headache. Usually I just get more caffeine. Okay, guys, I think that's it. So that was scalar energy. That's all I want to say about it. I don't really have anything else to say. So if you have any ideas for topics that you want to talk about, let me know. You can get a hold of me through the website, through the Facebook group page, The Interested Reader group. I'm on Instagram. The website is theinterestedreader.com. There's contact forms. However you want to get in touch. I'd love to hear from you guys. And let me know if the lessons are super boring, if you hate them. If you hate them, I'm probably going to keep doing them. You can just fast forward. What I'd like to do is get to the point where I actually can edit video properly, and I could put, like the link, or, you can say that the topic starts at X time. And so you could just skip over the whole lesson if you want, if they're super boring. But I love doing them, so I will keep doing them. But if you have feedback, please let me know, because I want to make them better. I mean, I'm really doing this to help somebody out there. Hopefully somebody's listening. I don't know. But I mean, I want to help. So if you have any questions, you have any suggestions, I don't know. I mean, I'm trying to improve my setup here. I know it's pretty janky. So I got that. I already know that I need to work on that. But if you have any suggestions about, I don't know, how I'm teaching or whatever, just let me know. Because again, it's meant to be helpful, and I hope it is. Let me know if it is helpful too, because that would be awesome to hear. I'd love to hear that. But I want to hear it all. I want to hear the good, the bad, and the ugly. Just be brutal. All right, guys, that's going to be it. Let me know what you think. Let me know if you have any ideas, suggestions, questions, whatever. All right. Hopefully I can get this. This one will definitely be posted on time on tomorrow, which is amazing. I did not think I was going to get this done. I thought it was going to be next week, so small win. I actually did something on time. So it's supposed to be every other week, so I'm supposed to be doing this every 2 weeks. So the next one, we're still hoping for 2 weeks from tomorrow. So tune in then. Hopefully there will be something to tune into. And I will talk to you guys later. I hope you enjoyed this episode and are inspired to question and investigate the world around you. Let me know what you're thinking about. You can contact me through the website, theinterestedreader.com, send me an email at sarah@theinterestedreader.com, or join the Interested Reader group on Facebook. I'll see you at some later time T, where T is greater than T naught, and T naught is equal to now. Thanks for being an interested reader, and I'll see you next time.